Welcome to Fish School episode 4. In this episode, we kill the Snot and get started on the player. Then, we kill them too. Let's pick up from where we left. I said we will need to make the hurt animations work for everyone by abstracting them. Well, I lied. Let's throw it all out to create a generic procedural hit animation that works for everything. I was only contractually obligated to explain animation parameters as a tie-in for our upcoming AnimGraph tutorial. We won't deal it much, just where we set the animation parameters, or you can keep them, it's up to you. If you do want to implement them for the player as well, the citizen comes with a hit animation parameter too, so all you have to do is set the intensity of the hit with the hit_strength animation variable. All difference is it goes from 0 to 1 instead of 0 to 100, so we'll have to divide it. There's other fine things you can do with the hit animation on the player if you look at the model renderer and see all of the animation variables you're provided with. I'm not gonna do that though, so I'll delete all of it. I'll keep the health animation parameter, but add a check to do it only for the Snot, so they shrink when they hurt. As for the death animation, the player doesn't come with one. I was thinking of ragdolling them, but we'll handle it with the player component, and for now let's move the code out into its own method. While we're at it, let's also give the player the unit component. Set to player team, name the player, and yeah. Go back to the damage animation and let's make it asynchronous with the async keyword. Now we are able to use the await keyword, letting us wait time in between lines of code rather than running it all at once. I'll start off by multiplying the renderer's local scale by 1.1. making it grow in size, then tinting it red. We wait 0.1 seconds, and lastly, we divide the scale by 1.1 and set the color back to white, which is the default. Now I say I'm multiplying the model's renderer scale, but really this is just a shortcut to the game object it's on, basically the same thing as typing tease. If you remember, we made sure to put all of the model renderers in child game objects. That way, we can modify the model's scale without having to worry about things like collisions or so scaling up and down, which will get pretty messy for our player controller. Imagine being stuck and suddenly you get damaged, you might grow into the world and creep through. We're passing a damage variable as well, so might as well put it to use. We'll have it dictate how long the animation lasts. In this case, if the damage is 50, it will last half a second. Let's save and try it out on the player. Looks good, but what about the Snot? Looks okay. I don't like how it instantly shrinks when it receives damage. It kinda negates the growing effect we did, so let's have the Snot slowly shrink instead of instantly setting it. Let's move the health anim parameter section from this method and put it inside of the onUpdate method, so it's done every frame. Since I said we would handle animations inside of these, let's also copy and paste the check if the model renderer is valid here, just to be sure. Now this code is going to run every frame, so instead of instantly setting it to the remapped health, let's have it slowly approach it. First, we get the current animation parameter from our model, and as you can see, we have to define we want to get the float this time. You didn't have to do it when setting it, because it will know from the second parameter you fed it. We make use of the matXLerp method, which stands for linear interpolation, don't ask me how, to approach the new health value a tenth of the way each frame, one being all of the way. Lastly, we set the animation parameter to this one instead. And now, when the Snot's health drops from 50 to 25, instead of instantly shrinking, it will slowly approach its target size. Something to consider though is that inside of onUpdate, it's called every frame, as opposed to onFixedUpdate. This code here might be called 30 times a second, but it could also run 500 times a second, meaning that the shrinking speed is tied to your frame rate. To fix that, we make use of time.delta, representing the time passed between frames. Just replace this fixed value here, and you can even speed it up by multiplying it. Now, this Snot will shrink at the same speed regardless of frame rate. Let's have a look at it in game. And nice. Also works when healing as well. It looks like we're inflating a balloon, which makes me think, Let's add a health regeneration as well. Let's do a new property, health generation, with a nice slider to go with it. And actually, since the editor might be getting cluttered, let's organize properties inside of their own categories. Make use of the category attribute, and let's put all of the health related ones into a health category. These two at the beginning can go into an info category, and here at the bottom, let's call it components category. If you look at the editor, they are now nice and organized. You can even collapse them. I guess the buttons need categories too. Let me put them in the health category. And now to implement the health regeneration, let's make use of a TimeUntil. Make a new TimeUntil private field called nextRegen. TimeUntil is a very useful type which can be used sorta like a timer. I'll show you why it's useful. Let's go inside of the onFixedUpdate method, which is where we'll put gameplay logic since it runs at a fixed rate. If nextRegen is up, heal by our health regeneration and set nextRegen to 1 second. Remember, we heal by doing negative damage, and as you can see, TimeUntil is very versatile. Here we are using it as a boolean, basically returning true when the time is up, and once it is, we can use it as a float to set it to go off 1 second from now. In fact, you could just check if it's less or equal than 0 and the result will be the same. Very simple logic. If we save and look at it in game, damage this node, you'll see it reinflates itself. Disgusting. And actually that's pretty overpowered. So let's set the nextRegen to 5 seconds if you just got hurt. This way you can't regenerate while being damaged. And for now, let's view how much health we have with a debug method to display text in our scene. We'll go over to the onUpdate method and make use of the debug overlay text method, setting the position of the text 80 units above the snot, with the text being our health / our max health. You can use variables inside of strings with these curly brackets if you add the $sign prefix before of it. Very useful. Save and check in game. Much better. Now it waits before regenerating after getting damaged, and you can actually see the health. Let's put an end to it by actually killing it once and for all. We can't just instantly destroy it once health reaches 0, because we want to play the death animation, and for the player I guess we want to ragdoll them, so let's make a new asynchronous method called kill. This time public, in case we want some logic in the future to kill all snot at once. And now call the death animation method here, and replace the health check so it calls the kill method instead. After calling the death animation method, wait a second, then destroy the GameObject this component is on. Make sure to call GameObject.destroy, and not just destroy. Otherwise, it will just delete the unit component and nothing else. Now remember when we added a check to make sure our model was valid before touching the animation parameters? Well, now we need to do something similar, but to check if this snot is actually dead, or else it will still be able to get damaged or regenerate while it's playing the death animation. Let's make a public alive field, set to true by default, and then set it false when we call the kill method. Now go around adding early returns to your code if this snot is dead. Add one here, right at the top of the damage method, so it doesn't run any code below if it's dead, and let's add it on these update methods as well. That should be enough. Now if we want to go in game and kill the snot, you can see it disappears from the hierarchy after a second, because it's been deleted. Of course the same thing happens if the player gets killed too, but I'd like to ragdoll the player and handle respawn separately. So let's finally make our SnotPlayerComponent. Go over to the player, new component, SnotPlayerComponent, etc. Let's add a few references to the components we'll need, once for the player controller, the model renderer and the unit component, and hook them up in the editor. Now let's make a method for ragdolling the player. It will disable movement and add the model physics component, which, when set up correctly, is going to turn our player into a ragdoll. Let's add the model physics component, use the add component method to add the component we're looking for, in our case the model physics component. These brackets here are called generics. To keep it simple, it's a way to pass types instead of values. Our class here is a type, See? It says declares types in namespaces, and if we copy and paste it here, it will create another copy of itself, I guess. Perhaps we'll explain generics more in the future. Now let's set up the model physics, target our skinned model renderer, which reminds me, let's not do any of these if the model renderer isn't valid as well. Can't be too safe. And then we need to set the model. We'll set it to the same model that our renderer is rendering. And lastly, let's disable the controller inputs, so you can't move around when ragdolled. I'm going to add a button attribute to the ragdoll method to try it out in game. Let's check it out. I guess we need to make the ragdoll ignore the player, because the collisions are still there. Good time to introduce the collision matrix. Remember how in the second episode we had to set up tags for the water and the ladder to work? Well, now it's time for us to make our own tag, and we'll call it player tag. We can just go to add a new tag to the player game object, write it down this time and press enter to add it. But this isn't enough for what we want. We want anything with the player tag to not collide against others with the same tag. So let's add that interaction in the collision matrix. Go to Project, Settings, and Collisions. There's the collision matrix, and a quick explanation. You can read it if you want, but for now we'll just add our tag. Click the plus, write player and enter. And now the collision matrix contains our player tag. You can see right now it doesn't have any special interaction though. More than likely it will default to colliding with the solid tag, which is added automatically to anything with a collider. Green check means colliding, red cross means ignoring, and the minus is a trigger. You can see that the water tag is a trigger, and that's what we use to swim. Not sure why the ladder isn't a trigger as well, but it's not my problem. Anyways, let's look at the player-to-player interaction by matching the row and column. Up here, the player tag column, go down and there's the player tag row. Let's keep clicking until it's set to ignore and save. Now that our player has the player tag and it's set to ignore anything that also has it, if we play and ragdoll, just as expected. And now, for respawning the player, we also want to have a way to unragdoll them. Let's store the ragdoll as a private field for use outside of the method. And use that instead. We don't want to create multiple model physics if we already have one, so let's add a check, and this time, if the ragdoll is valid, we do an early return. Now for unragdolling, copy the entire ragdoll method, rename it, and just do the opposite. If the ragdoll is not valid, then return, destroy the ragdoll component. See, this time we're destroying the component, not the game object, and lastly, re-enable the controls. Let's try it out in game. Ragdoll, unragdoll, ragdoll, unragdoll, perfect. All that's left is hooking it up so you're able to die and respawn. First let's save somewhere the spawn position and set it inside of the onStart method. In the future we'll have actual spawn points, but this will work for now. Create a respawn method, and inside of it we unragdoll the player, set the units alive value to true, set the health back to the max health, and lastly, place them at the spawn position. We're currently destroying anything after that, so let's change that for the player. Move back to the kill method in our unit component, and I know I said we would abstract this as well. Well, I lied. We're doing it the lazy way again, and just checking if we have a player component. Try to get the player component, and if it's valid, meaning it found it, ragdoll it, and then after the second has passed, and if the player is still valid, we respawn them. Otherwise, for everything else, we just go ahead and destroy it. Let's try it out. Awesome! We are finally able to experience death. I say that about wraps it up for now. Thank you for watching, and have a good night.